I want to be upfront about something. I have no idea how the next few years actually play out for software developers. I do not know if the next major model release finally makes my job obsolete, or if AI ends up being another power tool that makes skilled people faster and everyone else more confused. What I do know is that nobody else knows either, regardless of how confidently they are posting about it. But occasionally, someone worth listening to says something worth examining. Addy Osmani spent years working on web performance and developer tooling at Google. He is not known for hype. He is known for translating what is actually happening in the industry into practical implications for people who build software for a living. When he shares a take on where this is all heading, it is worth sitting with seriously. So, today we are going through his view of the next 2 years for software developers. The real shifts, the uncomfortable ones, and the ones that are already happening whether we have noticed yet or not. The software industry has reached one of those inflection points that only becomes obvious in hindsight. For a long time the story was simple. Software was eating the world, capital was cheap, and companies hired anyone who could credibly distinguish Java from JavaScript. Growth mattered more than efficiency. The answer to any engineering bottleneck was to add more engineers. Headcount was the lever. AI is breaking that assumption. Productivity is no longer strictly linear with hiring, and that forces companies to rethink what an engineering team is actually supposed to look like. Addy's argument is not that AI replaces developers. It is that AI compresses the distance between idea and execution. The friction that historically justified large teams is shrinking. Boilerplate, setup, repetitive implementation work, a significant portion of what junior engineers were hired to do, can now be automated well enough that companies are starting to ask whether the junior role makes economic sense at all. The early data already points in that direction. When companies introduce generative AI into engineering workflows, junior hiring declines while senior hiring stays relatively stable. A senior engineer with good AI tooling can now complete work that previously required multiple junior contributors. So companies stop expanding the bottom of the pyramid. Teams get smaller, more experienced, and considerably harder to break into if you are just starting out. From a short-term efficiency standpoint, this looks completely rational. From a long-term ecosystem standpoint, it is a slow-moving crisis. Every senior engineer was once a junior. If the entry path disappears, the industry eventually runs out of people with the foundational experience to become senior engineers in the first place. You cannot compress 15 years of career development into a prompt. Silicon Valley is trying anyway. There is a more optimistic counter-argument worth taking seriously. If AI dramatically lowers the cost of building software, software might expand into industries that historically employed almost no developers. Healthcare workflows, manufacturing tooling, agricultural automation. In that version of the future, demand for developers actually increases. But the shape of the role changes. Entry-level developers become domain specialists who understand both software and a specific industry deeply, rather than generalists who can write CRUD applications for anyone. Whether that future arrives or not, the immediate reality is already shifting. Junior developers can no longer rely on time alone to create value. The expectation has moved from learning slowly on the job to becoming productive quickly. The patient apprenticeship model is getting compressed. The skills question runs deeper than just hiring pipelines. AI tools generate working code fast, and developers adapt to that speed in ways that have side effects. Whenever a problem appears, the instinctive response becomes prompting rather than reasoning. You reach for the tool before you reach for the mental model. And over time, this changes how understanding develops, or fails to develop. A lot of newer engineers now encounter problems they never have to solve independently. They receive a correct-looking solution before they have built the conceptual framework that would tell them why it works. That is genuinely dangerous because AI-generated code often functions while hiding inefficiencies, security flaws, or architectural problems that only surface under scale or real stress. The code passes the tests. The code ships. The code fails 18 months later in a way nobody can explain because nobody actually understood it. A recent study found that 96% of engineers do not fully trust AI output. Only 48% consistently verify it before shipping. Read that again. Nearly every engineer acknowledges the output cannot be blindly trusted. Less than half actually check it. That gap between what people know they should do and what they actually do under deadline pressure is the real risk, and it is almost certainly widening. Deadlines do not care about best practices. They never have. The developers who come out of this transition well are not the ones who use AI the most. They are the ones who use AI while maintaining enough independent reasoning to know when the output is wrong. That distinction is going to matter enormously, and it is already starting to create a visible divide in engineering teams. The definition of a software developer is also beginning to split into two trajectories, and neither one is guaranteed to be comfortable. In the pessimistic version, development becomes oversight. AI produces the code, developers review it for correctness, compliance, and safety. The creative dimension of programming shrinks. Work becomes reactive rather than generative. Engineers spend more time validating outputs than designing systems. There are already early signals of this. Engineers reporting that more of their time goes to reviewing AI-generated pull requests, managing automated pipelines, and cleaning up edge cases introduced by code nobody fully read. It starts feeling less like engineering and more like quality assurance with a better salary. The optimistic version is more expensive to get to, but more interesting if you make it. As AI handles implementation details, developers move upward in abstraction. They define system architecture, decide how components interact, and orchestrate multiple AI systems and software systems into products that actually hold together. The job becomes less about writing code and more about having the judgment to know what the code should be doing. What both trajectories have in common is that narrow specialization becomes increasingly fragile. Deep expertise in a single technology used to sustain entire careers. AI shortens the lifespan of any niche by reducing the effort required to operate within it. Tasks that once justified specialization, UI assembly, boilerplate API work, routine database optimization, can be handled by tools well enough that the specialist sitting at that layer sees their value quietly eroded. The industry has seen this pattern before, from Flash developers to engineers who built careers on frameworks that no longer exist. The difference now is the speed at which it happens. What survives is the T-shaped engineer. Deep expertise in one or two areas, combined with genuine competence across adjacent domains. Enough breadth to make coherent architectural decisions, enough depth somewhere to be irreplaceable at something specific. Shallow generalists get exposed when complexity hits, narrow specialists get automated. The people who end up valuable are the ones who can move between layers without losing the thread. None of this is certain. The honest answer is that we are in the middle of a transition whose final shape nobody can see clearly yet. What is clear is that the comfortable assumptions, Samut, that time in the industry automatically translates to value, that deep specialization is a permanent mode, that the junior to senior pipeline sustains itself, are all under pressure simultaneously. The developers who navigate this well will be the ones who stay technically rigorous when it would be easier not to, who verify what they ship when deadlines push against it, and who build understanding rather than just output. That has always been the difference between engineers and people who write code. It just matters more now. See you next time.